Morning.
Good morning.
Good morning.
I sent you an email, but
I haven't
I
read it
tried
anymore.
to take the AP and I managed to get through the first one, but my internet crashed and the internet ran out. Or the time ran out.
Okay. Then I'll just excuse you from it. I can't do anything else. Yeah, I guess I did, right?
Yep.
And then just in 100 milliliters, and then if you stir it up with stirring rod, that'd be great. It should be pretty soluble.
I love your hair. Thank you. It's so good. I was like, who is that? Like this speaker, or do you want to?
You can have to stir it, so you could do it in that if you want. It doesn't really matter. That'd be fine. Okay, what am I doing? Good. Hey, all right. Okay. Good work.
There's some lumps in the bottom of the
You can
powder.
squish them and just try and, in the time we got remaining, just
Right.
try and get them. It's not a big deal. Okay, today's like the 21st or 2nd. What is it? 22nd? Thank you. So let's put that. Okay, Chelsea, since you're taking on your phone anyway, here. That's all right. It's not useful. You can take a picture of each side of that, and I can turn the lights up. Yes, that'd be great. Put that home. That would be so nice. Thank you. I don't think I sent that out. Good morning, Lola. Glad you're there. Did you get both sides?
Yeah.
Oh, you're quick. Thank you. You're diamond. Thank you so much. That is a big help. Okay, so that's one more there. So let's do like 50. I'll be a good teacher and give you a break. That's the exact. Okay. Good
I was
morning.
wondering if I could use my phone to see the answers that I wrote.
Yes,
Okay.
you certainly may. They're gonna bring you. Dynamite. Thank you so much. Just right here. You're welcome. Appreciate your help. Good. 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 10. Alex, there's plenty of room here. You want to come up front? Come on up. So there's 2 spots here. How about one of these? Because nobody's there yet. What the heck? Okay, so folks, we're going to try and push a lot through. I want to go through the quiz first that 12 of you took, which is better than last time. That's good. And let's have a look at the answers together. And then after that, we're going to do a lab. We're going to kind of do it half together, our lab, because I think it'll be a little quicker that way. All right? And I'll assign Lola. She's here, and I'll get someone at home, and Oscar can be in a group as well. And Feeny. Okay, so Feeny is at home as well. So for you 3, we'll put you in a group later when we do the lab, and those folks can help you. The lab, by the way, was just sent out. If you want to look at it in the meantime, by Chelsea. She put it on the chat. Yeah, so you have the lab. We're gonna do that later. Okay, for starters though, let's have a look at the quiz. I don't need my goggles for looking at the quiz. And I'll just read it and let's see what they put and see what we put. Again, I'm giving you half the points just for doing it because this is really the best way I can prepare you for the AP. So for starters, number 1, we've got this reaction with H2SO4 and salt and making 2HCl and Na2SO4. Okay, a student claims that the reaction is a redox reaction. Is the student correct? What do you got to check to see if it's a redox reaction? Redox. Got to kind of look at what, Anthony? The oxidation number. So let's just go through. If it's H2SO4, well, SO4 is what charge, Louisa? SO4 is what charge, Penelope? SO4 is what charge, Errol? 2 minus. And it's attached to two what? And H pluses. Please, when I ask you for ion, give me the charge. I can read H. Okay, I need to know. Oops, I need to know the charge from you. I need to know you know the charge. So if that hasn't been clear in the course, make sure you give me the charge. Okay, the next unit after acids and bases is all about charge. Let's do the next one. Everybody, Na is what charge? Cl is. If it's a redox, then I should change those charges on the other side. Let's see if we do. HCl, probably the H is, Cl is. Any change so far? Go to the last one. Na2SO4. SO4 is again. NAs are. Is this a redox reaction? In your own words, who can explain why not? Why not? What can you say? Okay, Anthony? Perfect. Stop right there. No change in oxidation numbers. Therefore, not a redox reaction. Okay, so that's all you needed. Let's see if Feeney said it's a double replacement reaction. Would that be enough to disagree with the student statement? No. You really do, Feeney, have to say what Anthony just said. You might not have heard it because it's kind of got a fan going. But he said if there's no change in oxidation numbers, then it's not a redox. And when we went through all of the oxidation numbers or charges, they did not change. So that's the bottom line. Okay? Okay. And I got Bella here as well. Good. And Sophie. You assumed what? Oh, they forgot the plus here. Okay. It is plus. Somebody forgot to write it in. Sorry. Okay, let's do number 2 then. Calculate the mass in grams of NaCl needed to react with excess H2SO4 to produce 3 grams of HCl. Assume that the reaction goes to completion. Okay, well, this is sort of a gram to gram thing, and I haven't done it. So let's do our plan over here. So we got what? We got grams of HCl. We got to change that, folks, to moles, HCl. Let's see where we're going to. They want the grams of NaCl. So we got to go from moles of HCl to, good, pretty good for a Monday morning. And finally to, yeah, let's do that real quick. So we got, I kind of got to do it on the side, but you can get the idea. Thank you. Going on to my next step. So grams HCl and molar mass, it's what, 16.5, 17.5, does that sound right?
Yeah.
CL's in the 30s? All right, find it out for me, somebody. Look in the back of your book. 35.5, thank you. So 36.5, Earl?
Yeah.
Okay, so 36.5. So obviously for this one, they do expect you need a calculator. 1 mole HCl. Good. What's the relationship in the equation? How many moles to how many moles? Good. Amina. Yeah, 2 of what to what? Okay, super. So 2 to 2. So essentially, I don't need to worry about it. Times 2 over 2. And then we're going to get now I need grams per mole of I need the grams of NaCl, which would be what molar mass for NaCl? Alicia? Thank you. And that's it. So 3 times 58 divided by 36.5. 2's cancel. And whatever you get, you get. Somebody can punch it out and see. And then we'd round it to like how many sig figs would they give you in the problem?
2.
2. 2. Listen. 0.4 is it? Okay, so I think it's, or is it 58.5? Like CL is usually 35.5. And then I got 23, but I don't know if it's 23 on the dot. Anyway, something close to that. Thank you, Lizzie. Okay, good. So entropy, 12.8, 4.8. Good. Grams NaCl. Okay, thank you. Let's go on. Unless you got questions. I'm sorry I'm kind of barreling through, but I know we have a lot to do today. Any questions at home? We okay with that so far? So grams to moles to grams. That takes care of A. Let's go to B. By the way, even though I tried to pick a quiz that was all equilibrium, they're all mixed. I can't have one that's pure chapter 3 or whatever. So, but I'll try and give you a heads up on what to study for this week as well. I guess I'll do a multiple choice this week, and maybe I'll do it on chapter 4 or something. Okay, I'll decide later today. Okay, continuing then. So we've got now our new reaction. We got methanol with acid makes this and H2O. And look at the K. What's that K mean? If it's a big number, Penelope, what does that mean in terms of the reaction? In terms of reactants or products, what does that mean if it's a big number? Lots of products, right? Whoa, it's a huge number. In fact, at the end, we'll have how many reactants left? Almost none. Almost none. That's a huge number, okay? So I don't know, whatever that is, 4,700 or something. Okay, so the CH3OH and HCl are combined in 10-liter sealed reaction vessel and allowed to reach equilibrium. How much water or this other chemical do they have then at the beginning? Zero. All right, good. Okay, so they told you nothing about it, so they have zero of that. So you got some of these both. And they're allowed to reach equilibrium at 400 K. The initial pressure of the vessel here is 0.25 and the other one's 0.6. Okay, does the total pressure in the vessel increase, decrease, or remain the same as equilibrium is approached? Justify your answer in terms of the reaction stoichiometry. Okay, look at the reaction stoichiometry, the numbers in front. That's what they mean by stoichiometry. Someone explain, because it's what's going to happen to the pressure. Chelsea? Exactly. And specifically, it's the number of moles of what on each side, Chelsea? Of gas. Notice we got 1 plus 1 is 2. 1 plus 1 is 2. If it's 2 to 2, it doesn't matter which side I go to. It's still the same amount of moles of gas. So for that one, what would we say then about the, who was following what Chelsea said? What does that mean? If the coefficients are the same, show the same number of gas on each side, then what's going to be true of the total pressure? It will what? And Sophie? Louder? It will stay the same. The total pressure will stay the same. Thank you. Questions on that, or folks at home? Type in if you got a question, okay? Let's continue. So many screens, I don't know quite what I'm doing. Okay, 2. Considering the value of Kp, and we've already considered that, it's really big. Calculate the final partial pressure of HCl after the system inside the vessel reaches equilibrium. Now, this is, I was talking to somebody last week about Ks, and if it's a small K, that's one thing. If it's a really big K, you really can't assume it's totally going to change over. Here's what I mean. I've got 0.250 atmospheres of this stuff. I've got 0.600 atmospheres of this stuff. So which am I going to basically run out of as this thing goes towards the product side? Listen again to my question. I got 0.25 atmospheres here. I got 0.6 atmospheres here. Look at the coefficients. What am I going to run out of? Penelope. Exactly, the 0.25 moles of CH3OH. Keep thinking that way. Now, how much will I have left of the HCl? Hint, subtraction. Errol, what can I do?
Subtract 0.250.
Exactly. So let's just all do that mentally. So 0.6 minus 0.25 would be Amina? 0.3, so we got 0.35 atmospheres of this stuff left. And I should have how many atmospheres of both of these guys then? Assuming I really do run out of this one. How many atmospheres of both this and this at equilibrium? Use the stoichiometry, Alicia? Yeah, 0.25 of both. You might say, Mr. Weiss, why don't I have to use an ice table here? I mean, you could, but it's a waste of time. Why don't you have to use an ice table here? In your own words, Anthony? No, the 2 to 2 it's helpful. I agree, Anthony, but it's not. It doesn't tell me I shouldn't use an ice table. Something else tells me I don't need to bother. I could do it, but I don't need to bother. Why not? Penelope. Yeah, the K is already given, and it's what sort of number? Big or small? It's a big number. So if we're going to assume it goes to completion, which in chemistry means it's going to make the products totally until I run out of somebody. So we already got from somebody, we're going to run out of this stuff. So really, we're going to make just that.
Good morning. Pardon this interruption.
I don't want to.
I'd like to take a moment to have a moment of silence for the tragic events that took place in Atlanta, Georgia, in the events against Asian Americans. So if we could please take a moment of silence to reflect upon these tragic events. Thank you for participating. Enjoy the rest of your school day.
Okay, let's read the question for 2. So considering the value of K, which we just did, calculate the final partial pressure of HCl. Now, notice this says the final partial pressure. Do I ever need that 10-liter thing? I don't think I do. Because it doesn't say the what? Concentration. It only says the partial pressure. So calculate the partial pressure of HCl afterwards. But you guys kind of already did that. What did you subtract? What would I write for the greater for II? Something really quick just to show I know what I'm doing. What would I write down? Ansel P? So give me the numbers. What do I subtract?
0.60081 minus 0.250 is equal to 0.35.
And let's label it. That's the pressure of what stuff again? Just so the grader knows I know what I'm doing, Alex?
HCl.
HCl, thank you. Ta-da! Isn't that cool? That's not a lot of work, but we just earned a nice point by doing just that little bit of work. I wouldn't just write down the answer. The math is so short, please show that subtraction for the grader. Okay? Any questions here? Yeah, exactly. Large K value is important. Oscar. Okay, so let's go to the third one. The student claims that the final partial pressure of CH3OH gas at equilibrium is very small, but not exactly 0. Do you agree or disagree with the student's claim? That's this stuff. Well, who can answer that? Would you agree or disagree that it's small, but not exactly 0? Penelope. Okay, what argument is it is exactly zero, arrow?
I say that C is correct because of the large K.
Yeah, I didn't hear the first part.
He's right because of the large K.
Okay, so the large K tells you that, but then, or is he right or is Penelope right? Should it be very small or should it be zero? Think of the mathematics. It's only going to be zero when? Yeah, really completion, like a million, billion, gazillion. It would have to be an infinitely high number. So mathematically, you need to say something like that. So first off, you got to say agree or disagree. We would say, okay, we would say agree. And a high K the high KP can I challenge you to make it into like a fraction in your mind? So first change this to a number. 4.7 times 10 to the third will be what number? Would be what number, Ellen? Times 10 to the third. Thank you. Can I put that over 1? What does that prove? What does that prove that they ask about? You know, that one more time? Huh? Well, no, it's 1. It's not 1 is not larger than 1, but remember I got products over reactants. I'm doing this as if I drew a K. Why did I do that? Why did I put a 1 here to have you think about this? Chelsea? There you go. So what I'm saying is if this is products over reactants, then yeah, I get almost all of this stuff, but I still got a 1 represented by the stuff on this side. In other words, mathematically, I've shown the grader that it's very small but not equal to 0. See what I'm saying? So KP means blah, 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 blah. So small but not 0 for reactants like the one they ask about, CH3OH. I know because you might think I'm kind of being really wishy-washy here. I know in the first couple of answers, folks, I said, well, it pretty much goes to completion. And that's right, but it's not 0 at the bottom because mathematically, I've still got a 1 down here. It's not a lot of reactants left, not much, but there's probably a little tiny bit, and that's what they say. It's very small. Okay, so you got to kind of mathematically shift back and forth. Pretty much all of this, but a tiny, tiny bit left for the reactants. Okay, let's continue. Again, let me know if you've got questions. I'm just cruising through here. And notice now we're going to a really completely different subject. But that's the way it is. So now we got 2 chemicals, CH3Cl, CH3Br, and they compare their molar masses, dipole moments, boiling points, and heat of vaporization. Identify all the types of molecular forces that exist among molecules of CH3Cl. Okay. Give me something that's going to be, Louisa. Good. So always you can write down London dispersion forces. And there's a second one you can write down for this one. Alex?
Dipole forces.
Super. So dipole forces, I'm going to erase my top answer here. I have a little room. So this is C. London dispersion forces from Louisa and Alex dipole forces, or you can call it dipole forces. Done. No explanation. They don't ask for it. II for C. In terms of intermolecular forces, explain why the boiling point of CH3 liquid is higher than that of CH3Cl. CH3Br is higher than CH3Cl, the boiling point. Okay, it's considerably higher. Something else in the chart is the reason, so to speak. Lisa? The molar mass is different. So now, what does that mean? You can't just say molar mass. What do they want? What do they want to make this? We need to talk about dipole. What does it mean if I got a bigger molar mass? There's what? How did we say it this year, Alex?
Stronger intermolecular forces.
Yeah, there's going to be stronger intermolecular forces. And which type? Stronger. No, stronger dipole forces. And somebody else, which chemical? Just so I know you're following. And which chemical, Alicia? Thank you. Since with a greater molar mass, and we can't use that as our answer, as tempting as it is, what is also greater? That it's a phrase that we kind of used when we talked about this long ago. Remember, Alex?
The number of electrons are greater than Br.
Good, exactly. We're going to say the electron cloud. The electron cloud. With greater molar mass, so greater the electron cloud in CH3Br. So that's the phrase I'd like you to try and use, electron cloud. I'll try and show my folks at home what I wrote over here. If you can read that at all. 4, 2. It's pretty hard to read. Okay. Let's go on. So now we're at D, I think. Again, this jumps all over the place. Typical AP question, a big mix. 2 milliliter sealed glass vial contains 1 gram of CH3Cl. Is stored at a freezer at 233 K. Okay. Okay. Well, that's in K as well. Okay, what do you notice about this temperature right now compared to these two? This temperature is, Amina, why is that important? Yeah, and check out the phase. It's a liquid. I got a gram of liquid. What's going to happen at this point and this point to our liquids? They're going to, Anthony? No, boiling point. That's not a freezing point. They're going to, Amina? And become what phase? A gas. So we're starting everybody with a liquid. Now let's continue with the question. Okay, first off, calculate the pressure in the vial at 298. Oh, assuming that all of this vaporizes, which is a pretty good assumption. I got 298. I want the pressure. I've got a gram of stuff. What are you going to use to solve this? Or what did you use, folks who got this far? Arrow? ideal gas law. So this smells a lot like Pibnert because it is Pibnert. So this is DI, and I'm going to solve for which thing? Which do they want? Looking for the Penelope? The pressure. Good. So P is N RT divided by that. Let's do it. For the N, let's do it within the problem. So I got to do what? 1 gram divided by, remember N is number of moles, so I can divide by the molar mass. So we did that already. What was it, folks? We figured it out earlier. CH3, or did we? No, we didn't. We didn't. What is it?
It says the molar mass up there.
Oh, it's up here. Weren't they nice? Okay, which one is it? That's sweet. Saved us the time. Okay, so which R value do I need? You would have those on the actual AP, but some of these probably should memorize for speed anyway. Alex?
It's the atmosphere one, which is like 0.008.
Yeah. 0.0821 liter atmosphere mole Kelvin. I only write the label to help me think about it, so I know I got it. And the temperature was, they gave us, it's what? 298. Okay, right? 298. There it is, 298. Okay. And divided by the volume, 2 milliliters. Okay, so we need to change that to liters. How you want to do it, Penelope? Good. Thank you. Okay, there you go. Whatever answer that is, that'll be the answer with what sort of label, because your grader will want the right label on it. It'll be arrow, ATM, atmospheres. You guys can punch that out, could you, and see what you get? Let's see if we get the same answer. Maybe somebody here's got it. You guys got it? Pivnard? Figure out the answer? Okay, here's the numbers over here. Okay, sort of see, I hope. But it's using Pivnerd, so I hope you'll get that. Okay, you got it. Answer, Anthony.
Sure.
0.82? Okay, let's see if that checks with somebody else. Yes, yes, no, no. Can I have a couple of you punch it out and let's just see. So 1 divided by 58, no, by 50, 50.5. A big number. Okay, what'd you get? 342? 244? Okay, so it sounds like that's probably it. So 240, rounded? 240.
Sorry. So what did it do? I just pulled the camera from here.
Oh, that's fine. I don't need it. Okay. Big or small pressure? Big. Big or really big? Really big. Guess why they did that? Let's read the next question. Why would it be unsafe to remove the vial from the freezer and leave it in a lab bench at 298? Good, Louisa. Yeah. What would it do? It'll explode. You can't hold that pressure, probably, right? That's a huge pressure. 240 atmospheres. How many atmospheres do we live under? What? Thank you. Isn't that a good question? They often do that. It has a little bit to do with lab safety, but really just kind of thinking. Okay. How many think they got at least half of these right? Okay, maybe half will be the half a night. Okay. Well, we'll see. I'll grade them here in the next couple days. And Feeney had that right as well. Thank you, Feeney. Appreciate it. Good. Whew. So that is our AP test. Questions before I kind of get rid of this? Any of the ones you want to ask about, either the format or anything else about the FRQ quiz here? Does that help what I'm doing? That we go over and talk about them? My hope is, because this is what last year's class suggested, that we do more small quizzes with the format so you guys get used to the format of it and kind of get an idea of what they want over time. Mina. Yeah, it needs to make a product, but it needs to have a little reactive left. Yeah, because it's a number, an actual physical number. Yeah, you can argue that way. That's something to be fun. Yeah. Good. Any other questions on any of the parts? Or anybody here? Okay. Woo-ha. Okay, let's get rid of this. Say goodbye. And roll this thing up. Okay. Folks at home, find your lab. And how about Alice? Could you give everybody one of those, please? Including yourself. I will turn this sucker off. My technical way here. Thank you so much. Great. Okay, so we're going to do this. No, that's all right. We're going to do this together to save some time. Let's go ahead and start reading. So how about Anne-Sophie with the overview? Folks at home, find that. Okay, the Henderson-Hasselbalch equation is what I call the handy-dandy buffer equation, okay? And we'll use that down in number 4 in a second. Okay, so number 1, prepare a buffer solution that contains 2 milliliters of 1 molar CH3COH and 1 molar blah, blah, blah. Now, 2 milliliters is a ridiculously small amount anyway, so I just had some help here before the hour. I had some help from Alicia, and she made the 1 molar NaC2H3O2. That's the sodium acetate stuff. And you made 100 of that, right? Yeah. And that's here. Super. And the other stuff, and I had Louisa pour out 50 milliliters of this. So this is, let me write it here. Oh, darn it. When is this thing going to go off, really? How come technology is such a pain in the butt? Do I got to hit it again? Can I do that? No, probably the battery's dead. What if I hit this really hard? While your other teachers get this frustrated, yeah, you're not alone. Thank you. Makes you feel like a dinosaur, but anyway. Okay, here we go. So this I got from Louise. I want to start with that. That's the 50 milliliters of NaCH3COO. Okay. What is that, everybody? Is that the acid or the conjugate base? What is this stuff going to be from its chemical formula? Is that a source of the acid or the conjugate base? Which one? Penelope. Conjugate base. You can tell somebody else, you can tell it's not the acid because what's it missing at the beginning? It should have amino of an H. So that's definitely the conjugate base. And it's 1.0 molar, by the way. Wait a minute. Yes, except I did the wrong thing. You measured out the acid, didn't you? Yeah, so right answer to my question, but it's not what I did, so I misspoke. So I gave Louisa that stuff. Okay, so I had to measure out 50 of the conjugate acid, pardon me, and I had Alicia measure this stuff out and make some of this stuff up. And we know that now because we talked about it already. Question is, Oli Prioli. Yeah. Right here at the top. It says procedure. We got the CH3COO and NH. That's the same stuff as this, okay? I'm sorry they write it different, but it's the same chemical. Okay, so it's those two chemicals. Okay, well, it must be early in the morning. So my question to you is, I want to make a 1-to-1 buffer. How much do I got to add of this stuff? Of the base? I got to add, Penelope, 50 milliliters. So let's go ahead and do that. So there we go. Chelsea, you add 50 of this over to this, so we'll end up with 100 of this stuff. Here's a pair of goggles you can throw on. 50 of this. Yeah, so we want to get that up to 100. And then we have 100 milliliters of our buffer. Now let me just think about this with you, because I think I sort of screwed up, but I did it quick. We can still do the lab, but what concentration will the buffer be? Why? You're right. We're diluting them both. By what factor, Anthony? It's in here, right? Thank you so much. Well, careful. I don't think you mean splitting in half. We're doing what with the volume? Not half. Doubling. Okay, so we're doubling the volume. So can you just no, that's actually okay. That's what they wanted to do in the original, isn't it? No, that's okay. All right. So we got 0.5 molar. Thanks, Antonine, of our buffer. So we got 100 milliliters, 0.5 molar buffer. Ute. Now, I'm gonna actually probably we should do it. I don't think we do that. So not your fault. Look at the next thing, folks. Number 2. What do they want there, Louisa?
Zero point 1 mole CH3COOH and 0.1 mole NaC2H3O.
Okay, once we do that, what will be the concentration of that buffer? What will be the concentration of that buffer? And Sophie, you got it, molar, right? Yeah, 0.05 molar. Because it's a half like we did with Anthony a moment ago. Let me tell you where we're going. We're going to test amounts of these buffer in like a test tube. We don't need much. We got plenty. So I've got way more of the first buffer than I needed. Question, can I take some of the first buffer to make some of the second buffer? I can't. Figure out, use the dilution formula or logic. How much of the first could I put into a new graduated cylinder and then add distilled water? How can I water down the first one to get the second one? Think about that while I get a graduated cylinder. So we want to put in Sophie 0.05 molar buffer. And I got 0.5 molar buffer. Okay, how can I do it? You can just about do this one mentally. Ellen,
0.5
just a little louder there.
Okay, so you can take 90 milliliters of water.
Good, okay. So let's look at that, what she said. So she said take 10 of the buffer solution that we already made and 90 of that. Yeah. If you didn't know that, stay here just a second. If you didn't know that, could you do this? You remember that cute little equation? It's a good one for dilution. It would be what? It would be like 100 at 0.05, and then it'd be like X at 0.5, and you'd still get 10 milliliters either way for the amount, okay? We're gonna do that right after break, and then we'll test our buffer. We'll take a break, and then this should go pretty well. Then we'll put you in groups to answer some questions. Okay. All right. How about I ask Errol, could you get me a test tube rack with then 2 test tubes? That'd be great. And I will get 3 molar HCl. And I will get universal. Thank you, Ariel. Great. Okay. Good. I'm going to show some of this stuff to you, my studio audience. So, here's our buffer. So there's the 10. Okay. Need the 90. 90 of the steel. Okay, so there's my 1-to-1. Okay. Chelsea, just hold on to that. Remember, that's the 0.5 holder buffer, so I don't screw up, okay? Because I'm doing all this kind of fast. Super. All right, let's rinse that. Here's my buffer. Good. Okay, so there's my 0.5. There's the root buffer. There's the, not yet. If I put it up here, I'm afraid I'm going to forget. So. Okay, studio audience, we're going to get down here. So you may want to have a place to write your data. We're going to do this bottom chart. If you can print it out, fine. If not, you may want to have a spot in your notes to write this data, okay? Buffer 1, buffer 2, and the color changes. By the way, everybody at home, the number 3, the Ka for number 3, it's 1.8 times 10 to the negative 5th. Got that? Number 3 here in the lab, 1.8 times 10 negative 5th is the Ka. Write that down. You can't see anything. Lola, I'm sorry. I will put up the video and maybe that'll be helpful later. You can look at some of it in the video. Unless I crash. Hopefully I won't. Okay, all of my folks here, you can write down the Ka. That's number 3. So there's the number. It's from your book, but you just write it down. Okay, so I need some help here. Okay, so this is, you got the strong buffer, right? Okay, so I just added 90 milliliters of H2O as per Ellie's suggestion to 10 milliliters of the strong buffer. And so now I've got this stuff, and I'm going to put just a couple milliliters in here. I'm going to estimate in the interest of time into one of the test tubes that Arrow got me. So let's say that's a couple milliliters. Okay, I need here, I need two people. How about Ellie and Alicia? You're going to be in charge of this. This is the weak buffer. Why don't you come on up? Actually, grab a couple goggles and come on up. I better put some on too. And then I need another team. How about Anne-Sophie and Amina? And you got goggles, and you're going to do the other buffer. There you go. Add a drop of that, and you can kind of mix it in, okay? Okay, strong buffer. All right, okay. Now, you two, I'm going to hold this and find everything in my mouth. In this lab, why do I want the same amount, folks? Just one, and then get that get the universe indicator from them. So, folks at home and folks here, so I got one team. I got Ellie and Alicia. Got the 0.50 buffer. Let's call them number one, okay? Buffer one. So it's the point. Yeah, they're the weaker 0.05 molar. And then I got buffer two. So that's this here. And I got buffer two. That's 0.50 molar, and that's and so we okay, everybody, to get the pH, can we go back? You guys just hang out for a sec. Go back to number 4, the Henderson-Hasselbalch, okay? Let's look that up. Somebody look it up for the pH. Penelope. Good. And what's the ratio here for both my two teams' buffers, so to speak? Penelope? 1 to 1. So you know it's just the log of 1, which somebody told me the other day is 0. So we got plus 0. Okay, so that's 1 to 1. So just write that under number 4. So essentially, folks, the pKa, so it's the negative log of this. So can you find out what's the pH of this thing? Somebody crunch it out and let me know. The negative log of the Ka, 1.8 times 10 negative fifth. Please punch it out. And let's agree on an answer. Thank you, team. We're almost ready to start. Thank you for your patience. Okay. Folks at home, we're just getting the pH of this thing. Okay, so there's the equation. And we're going to put in the number. And the pH is, what did we get? Anthony? 4%, is that check? Is that acidic or basic, people? Acidic. You both groups hold up your buffers here to the group, not to me. I know what they are. Okay, are they about the same color?
Yeah.
Why? Yeah. Does it matter the reason that one is a lot? Does it matter that one is a lot weaker than the other? No, because they both have what ratio of acid and base? 1-to-1, weak acid, conjugate base. How cool is that? Okay, I need to separate you two. Okay, so I want my team one, buffer one here, and standing over there, my buffer two. And Sophie, go over there with Amina.
For the calculated pH, we just write 4.7 for both.
For both. So ironically, the pH for both of these is identical. Let's look at the color. So for the colors, for both groups, it's kind of orangey. Okay, so it's a little on the orangey. We're really going to look for any. Okay, so here we go. What I'm going to add is pretty much close to 3 molar. It's 2.7 molar. 3 molar H drop. And it says, count the drops needed to cause a color change. Okay, ladies on both sides, I'm going to have you grab a piece of paper to hold behind that for the studio audience. And we'll show this to our folks at home as well. The Ka, Bella, was 1.8 times 10 negative fifth. Okay, no, you can stand out there. You don't need to be by me.
Well, I mean for the.
Yeah, I'll write some down on some data. I'll be the secretary. Okay, now, here we go. So, I need everybody to tell me when we get a color change. And we gotta count drops. Here's my 3 molar HCl, okay? So pretty strong stuff. Okay, so I'm gonna put in 1 drop and ask you to look, everybody. Is there a color change? Already, good. Mix it with your thumb a little bit, Ellie, like I taught everybody. Exactly. And then once it's all mixed, everybody describe that color change. We can also compare it to the other group if we need to.
It looks the same to me. It looks the same.
Go compare it to the other group real quick, Ellie. Is it changed or is it a little darker? It's the same?
Yeah, it's like a tiny bit darker. No. It's a tiny bit redder, but.
That's what I need to know. If it's redder a tiny bit, then we gotta write down how many drops that was. 1 drop. Okay, so this is my team 1 here.
No.
So, folks at home, we're at the bottom now. Everybody here, we're filling in this chart. So I've got.
So the initial pH is 4.7.
For both. Like we said, yeah, for both. Okay, so we're not going to worry about the pH of each color, not at this point. But we can kind of worry about that a little more towards the end. Okay, here we go. You get another drop. Okay, so here we go. All right, everybody watch here and let's see how it goes. Okay, you have to mix that a bit, kind of land it on the side. Color change, yes, no.
Yeah.
Yes, oh, with even 1 more drop. Okay, so to get the second drop, the drops was, what is it now, pink?
Yeah.
Pink, and here it was like dark orange. And here it was orange.
It looks like a peach color.
Peach is also absolutely okay. Write peach if you want, that's fine. Okay, then let's go to a 3rd drop and see what happens here. Sorry, it hit the side again. You may have to kind of shake it a little bit.
Oh. Now it's definitely.
Okay, now this is color change. I feel like before it was like a pink orange, and now it's actually
Pink, orange, okay, now it's pink.
We could call it a peach. It looks like. Or know what kind of thing.
Bubblegum, yeah.
Okay, one more.
Bubblegum, that's my.
All right, one more. Here we go. I'm doing this because each time I'm getting a color change. That's why I'm stopping at one drop.
Looks like coffee. Oh.
That is about, this is universal indicator. So when it's on the acid side, already it's going to be reddish. So you know what? We're pretty much done with your group.
I would call that like a hot.
Yeah, it's like coffee.
Hot pink. Okay, hot pink. Okay. Okay, so I'd like you to show that to the folks at home. Could you? So you can show what color Ellie that you've gotten to. Thank you, Ellie. Okay. And I think we're going to stop this one. I think we already got it to red leaves. Exactly. Exactly. Okay, before we start, Anthony, can you show the color to the folks at home? Thank you very much. You can just sort of, yeah, I think I should put it here. Thank you so much. Good. Okay, now we're going to do with Amina and Aunt Sophie's group here. And what we're trying to do is we're trying to get the same color drop and see what happens for this group. Color drop. Color change. Sorry. Okay, here we go. So what do we want? First change, we want to go from orange to dark orange. Okay, so here we go. I'll let you bang it. There you go. Any change yet, folks? No, let's add another drop. Oops. Kind of 1.5 there, but that's all right.
There's no change.
No change? Okay, let's do another drop.
Three drops, right?
3 drops, yeah.
That's awesome. Still no change.
No change. Okay, I'm going to add a couple at a time here. We're up to like 5 drops.
Yeah.
Okay, that's about to dark orange now. So they got about 5 drops for their first change. Now we're going to pinky peach. All right, you ready? We're going for pinky peach. Let's do, I'm going to do a couple at a time because obviously we're going to need more for this buffer. Okay, here we go. So 1, 2. You got to decide if it's up to pinky peach again like the other group had. That's the same thing. Okay, 2 more. So now we're up to 4 drops.
4 extra drops.
4, yep. Are we at pinky peach? Or no? No, let's add, okay, so now we're going to add a couple more.
Yeah.
Yes, yes, no, no. Not really. Okay, so we're up to 6. Now we're going to add 2 more. No? Okay, let's add a couple more. So up to 10 drops. 10. Thank you. Okay, so
It just
10.
changed really quickly.
Oh, yeah.
To like pink instead of. Was it up 10 extra drops? Or
That's, yeah, that's an extra.
It like skipped a color though. Now it's like already hot pink.
Then you know what? Let's do this, Alex. So we kind of missed the peach. Okay, let's do a couple more till we get a real hot pink, okay? All right, studio audience, so we're on the last column, essentially, for this. So I'm going to add 2. 1, 2. Go ahead, mixer. Not yet. Okay, we'll add 2 more. I think we're done. Is that about the same? You can kind of compare now.
Yeah, that's it.
Okay, so we have 4. Good. You can set yours down over on the other side. Thank you very much. Appreciate it. Good. So we've ended up with the same color, both groups. Okay. But the number of drops to cause that is extremely different. So let's go and we're going to meet together for about, here's your mini lab, okay, folks, your mini lab. I'd like you to meet and you can talk with a person at home as well. So what we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's do like 2.5 people. No, that would hurt the half a person. Let's do let's do 4 groups. Let's do 4 groups. I'll do some 2s and 3s. Question first, Anthony. I would say it's useless. That's a good way to say it. It's certainly not helping. If it was designed for a purpose, it's not going to help that purpose anymore. Good. All right, here we go. So once I assign you, you can get with your partners and maybe call with your phone if you know your partner person at home. At home, I've got Lola, Oscar. I think I got you 4, and I think that's it. Do I got everybody? Okay, so let's do it. Do I have some cards for you after all this time? Just for grins, because I like cards. Okay, I don't have an Aiden anyway, so I got some other groups. 1, 2, 3, 4 over here, and let's do it this way. Sorry, I'm trying to see if I get somebody in each group who can do this. Okay, all right, so let's try this. So see if you can get the folks at home. Why is there a line in every row? The lines are just to spread it apart. It's a 1. This is 1 drop, 1 drop, 1 drop, 1 drop. Exactly. Thanks, Bella. Exactly. It's 1 drop. Okay, so speaking of Bella, can I have Penelope, Alicia, and Anthony maybe call or somehow text or something with Bella? So you'll be one group. You can get together when I'm all done. And then I got Amina, Errol, and Chelsea. Can you guys talk to Feeney? And then you'll be a group. And I'll tell you what to do, everybody, in a second. Then I got Louisa and Ellie. Can you guys talk to Oscar? And then you'll be a group. And then I got Anne Sophie and Alex. Can you guys talk to Lola? And I think I got everybody. Yes, yes. Good. So my groups, let's take like 15, 20 minutes and find a sheet of paper to write. And I'd like you to, for your lab grade, you're going to answer 1 through 5, you and your at-home partner, and I'll come around and help you.
Can we do it on the back?
Yeah, I guess. A line paper would be nicer.
Wait, Oscar doesn't have WhatsApp, right?
You can ask them up front. You can ask them if they got a phone number or something too. You can talk to them up front.
Yeah.
You want to call?
All right, we okay, people at home? You're all working with somebody, I hope? That works remarkably well.
The lab she would use online, I mean like on WhatsApp.
You hang up on me on here. Oh, wow, okay.
Hey, what was the I was looking.
It's more fun. Okay, I got it. Okay. Do you have FaceTime? Can I put your FaceTime? I'm not at home right now. Oh. Okay, so
Was there a difference between calculated pH and pH I would say yes. Because it was more basic. Oh. But it's still got your voice in it as it was.
Okay, let's see how we're doing.
I don't know what color the integrated is.
First one. Or I feel like it's universal.
And so that was one.
Was there a difference between the calculated pH and the number one?
No, because the calculation was 4.7 and the indicator was 4. Yeah.
Yeah, so it's about the same. It's sure what it's supposed to be.
Well, I mean, I was very concerned with color because the first thing that we got was 4.7. And so so the calculated pH was higher than the pH specified by the indicator.
What is the relationship between the pH and the pKa for the initial bonus solutions? Oh, okay.
That's all.
Explain this relationship. What is
so because we did that, both of
Wait,
What's the relationship between the pH and the
okay. Ms. Weiss, is the Ka the same for both chemicals?
At the beginning, yeah, it's the same chemical, so it's the same pH. It's the vinegar acid.
How do we explain the relationship?
Well, they both have what relationship between the amount of acid and the amount of concentrate. It didn't matter necessarily whether they were strong or weak. Which one? K gives the negative wall of the
Did you hear that, Lola?
Yeah.
All right.
yeah, because it's 1 to 1, so the other two drops out.
Was there a linear relation?
Okay, so,
In the first one, yes.
Just in the second one. Oh, we didn't read the reading.
we have a one-to-one relationship. I can also just send you the answers. Send you pictures of them. So that you're like, here's that. It's kind of hard. You needed like about 5 extra drops. Or 4 extra drops. Basically, we just set it for MPK or how to say value in the initial solution. Have a one-to-one relationship. Yeah, so they measure the one-to-one. So the log of the concentration of P1 to H minus alpha.
Yeah, that's,
It's an observation or 10 lines of
Okay.
I'm not quite sure.
Wait, do we have the same? Yes. Depending on the number of the upper, every buffer has the specific capacity, so if it's like, so it just says that buffer 2 has a like bigger capacity because it needed more drops for the tip cycle buffer than you did for the 0.05 or buffer because you could easily get it more acidic. Or the same number of drops also trying to color and extreme observations in light of what you see really so yeah. Um,
Was the number, or was the same number of drops? No.
So
And I know, which one's that linear question? Number 3? Okay, for number 3, I know the top one's sort of linear, kind of, but really where we saw the color change was pretty random. Look at the bottom numbers. It's not a linear relationship, really. By
So
any
you
means.
said negative one?
I don't think either one are. And if you think of the graph we did for titration, think of that curviness of the graphs we've drawn. They're not really linear functions. They got that curvy
so they're both. these graphs where it's like, you know, it's like walking. So based on what we know about these, because the graph is changing which basically means in the question. Okay, so the graph would be linear between on a rapid equals to equal point. Does that make sense? I'll just tell you the answer after your number. It's not your head. Okay. Yeah, hopefully I just forget what I want to say after like the process of saying it.
Even though we're working to reduce the
Yeah, there's so much CO2 that we can start
but will the capacity decrease quicker with even with the less CO2 emissions? What do you think that will have an effect on how fast?
I think that there's already too much CO2 that it will take a while.
I mean, there's so much CO2 and there's also so much H2O, so more H2O and reactions. More carbonic acid, so.
We should probably look up that.
Yeah. I will obviously. The capacity increased on the second one. On the first one.
Oh. Oh, wow. Oh,
I mean, considering how the question is right.
Oh, there we go.
We get to start out with this.
Oh,
We're
yeah.
gonna have to do it.
Well, that's
Like, way, yeah.
oh my God. What the heck? Oh. Oh, it's. Oh my God.
You need to combine water. How's that?
So the internet says that the past 750,000 years, the pH of the ocean has been stable and slightly alkaline at 8.2. Oh, we have carbonate buffers. Oh. So, I don't think it's gonna take that much.
Yeah, but it's fine. Oh.
Okay, public comment, that's okay?
What's the same number of drops in your
concentration of the buffer of the water.
Yes, good, I like it. So in other words, you're on number 5, right?
Yeah, but the internet says that the buffer has been stable at 8.2.
Not forever. So the most CO2, what did you say is gonna happen? What else is it gonna make the water go?
Well, it's gonna create carbonic acid.
Yeah.
Will eventually yeah.
Yeah, but we have to.
Concern for oceans.
That's about the speed, not just
Okay,
what.
number 4. Users look at how fast number of how fast they can change in the past, and it's been relatively stable for the past 750,000 years.
Yes,
Okay, now we're back. It should be.
Let's get down to
It should.
We're increasing CO2, we're changing the system that hasn't been that concentration of CO2. So now someone's gonna change the
It'll
system.
decrease quicker than it has.
Yeah, the capacity, we don't know when that'll be reached, but certainly the increase a lot. Right, and there's specific natures that it can get.
You're good. See you.
Bye, Lola.
Class over too.
What's the problem? Okay, so
We're really far behind. Number 4.
for everybody, I got to break off just with you for a moment. Let's talk about how to do this. So I'll accept. This is for online people too. I'll accept your answers to 1 through 5. Either you can give it to me today, or if you're at home or you want to finish it at home, that's just take a picture. Make sure I know who you are. Well, I will, because email it to me. Email me your picture for the grade as well, okay? Now, tomorrow, we can't have class at our time, but it's for a good reason. I've got an intermin. Wednesday, I'm going to get the AstraZeneca. So I will be getting IMP during our class time. So my question, Wednesday, either Wednesday afternoon or tomorrow afternoon, is there a time that would be open where we could do like an hour, hour and a half meet? Can we throw out some times? You guys know your schedules. Seniors will have to help us with their schedules. And Sophie,
Anytime until like 4.
what day?
On Wednesday after like 11, like 12:15 until 4. I have a call with like Miss Gephardt for registration at 12:30. Yeah, I got at 1. Yeah.
At 1.
Yeah.
Okay, can we schedule for later Wednesday afternoon? Can I ask anybody, what about 3 o'clock, 1500 Wednesday afternoon? Would that be possible?
Yeah.
Yes? Folks at home, especially seniors, 1500, 3 o'clock on Wednesday, would that be possible?
We have English that hour.
Do you have English that hour? Shoot.
I don't know if we're gonna have.
Have you been meeting regularly or not?
Well, we're at school, and she hasn't announced it whether we're gonna have online class that day. But I can't assume that we didn't. I have no idea.
All right. How long does that go? Till 4?
That's 8 to 9 hours. So 2:15 to 4.
Okay, I tell you what, let's do it this way. Folks, let's say Wednesday afternoon. Let's just do it that way, Alex, so we know the seniors are covered.
Okay.
Let's say Wednesday at 4 in the afternoon. That way my seniors are done. And I'll try and make it 4 to like 5:15. We can finish the chapter in the time and start the last chapter at least, I think, during that time. And maybe take a couple of questions from you. That's okay.
I can.
I have a Chem lesson at like
Oh, God.
4:45.
I can, Mr. Weiss, I can email you the day of or the day before if she says that we don't have a
Are you
class.
meeting today, Alex, or when will you know?
Well, I have in-person class today.
Then can you find out today and
I'll
email
ask
me?
today and email you.
Thank you. Okay, now let's do this. So what we'll do is 3 o'clock on Wednesday if we can. We'll find out from Alex if it's okay with the English teacher. And if not, we'll do 4 and we'll just have to have the rest of the day or something. Okay, so 3 or 4 on Wednesday. I'll send all of you a Google Classroom type link. Class went so well. Thanks for everyone, especially for participating with your at-home person. That was really good. I'll take them if you're done. Got your name up? Super. Dandy, thank you, Alex. Claro, pero
I know, I'm gonna do them now, so once I'm done,
okay, so we're gonna end that.